Hello everyone and welcome to this presentation on instance-based learning. In this session, we will be exploring some fascinating concepts that are central to the field of machine learning, including k-nearest neighbor learning, locally weighted regression, radial basis functions, and case-based reasoning. Instance-based learning. In instance-based learning, a machine learning approach where the model makes predictions by comparing new data points to stored examples from the training set. Instead of building a general model, it directly uses these examples to find the most similar instances and bases its predictions on them. Now let us discuss the main key concept of the instance-based learning. So in instance-based learning method, there are two types of learning methods in instance-based learning, like nearest neighbor and locally weighted regression. These are the straightforward approaches to approximating a real valued or discrete value target functions. Learning in these algorithms consists of simply storing the presented training data. When a new query instance is encountered, a set of similar stored instances is retrieved from the memory and used to clarify the new query instance. Instance-based approaches can be construct a different approximation to the target functions for each distinct query instance that must be classified. Now let us discuss the advantages of instance-based learning. The first one is the training is very fast. In the instance-based learning, we can train the model very quickly in a very fast manner. And the second advantage is learn the complex target functions. This model learn the target functions which are more complex. And the third one is don't lose the information. Instance-based learning model do not lose the information. It retrieves all the information which is stored. Okay, now let us discuss the what are the disadvantages of instance-based learning. The first one is the cost of classifying new instances can be very high because due to the fact that nearly all the computation takes place at the classification time rather than when the training examples are first encountered. And the second one is in many instance-based approaches, especially nearest neighbor approaches, it is that they typically consider all the attributes of the instances when attempting to retrieve the similar training examples from memory. If the target concept depends on only a few of the many available contributes, then the instances that are truly most similar may well be a large distance apart. Now let us move on the k nearest neighbor learning. Let us discuss how this k nearest neighbor learning method works and what is the key concept. The most basic instance-based method is the k-nearest neighbor learning. It is a type of a instance-based learning method. In this algorithm, it assumes all the instances correspond to the point in the nth dimensional space, that is Rn. It is a dimensional space. It assumes that all the instances are the points in that dimension. So, the nearest neighbors of an instances are defined in terms of standard Euclidean distance. We use standard Euclidean distance in order to find the distance between those instances. Let an arbitrary instance x be described by the feature vector a1x, a2x, and an of x. The instance x can be described by the feature vector. So here ar of x denotes that value of the rth attribute of instance x. For example, let us consider two instances, that is xi and xj, defined by the distance dxi of xj. In order to find the distance between these two instances, we use the following formula as shown here, dxi, xj. We use this formula in order to find the distance between two instances. So, in the nearest neighbor learning, the target function may be either discrete valued or real valued. There are two type of target functions. It may be discrete or real valued. So let us first consider learning discrete value target function of the form f from r power n to v. This is a discrete value target function where v is the finite set of v1 to vs. Suppose we want to find an approximation value for a discrete value target function, then we will use this k nearest neighbor algorithm. So in this we have two algorithms. One is for training algorithm, where for each training example x comma f of x, add the example to the list of training example. Training example is a data set where we are adding the training example to this. And the second one is classification algorithm. Here, first, we have an instance x comma q which is to be classified, and let x1 to xk denote the k instances from the training examples. Training example is a training data set where x1, x2, x3 like xk. These are the training instances stored in the training example dataset, and these are the nearest to the xq instance which is need to be classified. So the nearest neighbor can be classified by using this following formula, and here delta of a comma b equal to 1 if a equal to b, and where delta of a comma b equal to 0 otherwise. By using this formula, we can find out the nearest neighbor of the given instance xq, which needs to be classified. In the previous algorithm, the value f cap of xq returned by this algorithm as its estimate of f of xq is just the most common value of f among the k training examples nearest to the xq. So in that, if k equal to 1, then one nearest neighbor algorithm assigns to f cap of xq the value f of xi, where xi is the training instance nearest to the xq. Large, Larger value of k, the algorithm assigns the most common value among the k nearest training examples. And let us see the another k nearest neighbor algorithm for the approximation of real value target function. This is the algorithm which is used to find the approximation of a real value target function. This is similar as previous algorithm, but the change is the formula that returns the k nearest neighbor value. This is the formula which return the approximation value for a real value target function. Now let us move on to the concept locally weighted regression. Before moving to the locally weighted regression, first of all, we need to understand these terminologies. The first one is regression means approximating a real value target function. The exact meaning of regression in the machine learning is approximating a real value target function. And the residual, what is residual? The residual is, it is an error in f cap of x minus f of x in approximating the target function. This is an error between difference between f cap of x minus f of x, which occurs when approximating the target function. And the kernel function is a function of distance that is used to determine the weight of each training example. In other words, the kernel function is a function k such that wi equal to k of d of xi comma xq. This is a kernel function